Hi class, in this lecture here we want to talk about graphs of other trigonometric functions by looking at both the graphs of the cosecant and secant functions. Now I can't stress this enough. You need to know, before you jump into this, okay? You need to know how to graph both y is equal to sine of x and y is equal to cosine of x to do this, okay? You're going to notice that I'm going to talk about how you graph these cosecant and secant functions in terms of graphing first the sine and cosine function. And I'm going to set this up throughout the lecture so you'll understand where this is all coming from. But if you're jumping into this without having a really good understanding of how you graph sine and cosine, then you really need to go back and watch those lectures first. Okay, because when I get to the parts where I'm going to sketch sine and cosine, you're going to know I'm going to go through that really, really quickly because I'm going to assume that you have mastered that or have watched those videos. Okay, so here's what we're going to do. We're going to start by talking about how you understand the graphs of y is equal to cosine of x and y is equal to secant of x. I'm going to just do the basic graphs of those. And then what we're going to do is we're going to talk about how you graph variations of y is equal to cosine of x and y is equal to secant of x. And I'm going to do the basic graphs of cosecant and secant, and then I have two examples of variations of cosecants and then cosecant graphs, and then I have two examples of secant graphs. All right, so let's jump right into this. So when we're going to obtain the graphs of cosecant and secant curves, okay, we're going to do it by using the reciprocal identities. Okay, so the reciprocal identities are the following. Cosecant of x is defined as 1 divided by sine of x, and secant of x is defined by 1 divided by cosine of x. So here's what we do. We obtain the graph of y is equal to cosine of x by taking the reciprocal values of the graph of y is equal to sine of x. Okay? Now here's the deal. Vertical asymptotes of y is equal to cosecant of x occur at the x-intercepts of y is equal to sine of x. So when sine of x is equal to 0, okay, because remember you can never have a divide by 0. All right. What we're saying here is cosecant of x has vertical asymptotes. Okay, and you'll see this when I go to set this up, okay? And then the same thing is this. We obtain the graph of y is equal to secant of x by taking reciprocal of the y values of the graph of y is equal to cosine of x. And vertical asymptotes of y is equal to secant of x occur at x-intercepts of y is equal to cosine of x. Because at x-intercepts, y is equal to 0, okay? So when cosine of x is equal to 0, secant of x has vertical asymptotes. And that's going to be incredibly important to helping us graph, okay? Incredibly important. And you're going to notice basically what we're going to do is finding those x-intercepts, okay, where sine is equal to 0 and then where cosine is equal to 0 is really going to be really important for helping us sketch these graphs. Okay, so let's start with cosecant. All right, just to get a basic idea here. All right, so let's sketch the graph of, let's look at y is equal to cosecant of x, and let's just sketch it on negative pi to pi, okay? And this is how you're going to do it, all right? Every single time, okay? So always recall that cosecant of x is equal to 1 divided by sine of x. All right, so when you want to sketch y is equal to cosecant of x, first sketch y is equal to sine of x, okay? Do that, all right? And you're going to notice when I sketch y is equal to sine of x, I'm going to do it as a dotted line, okay? So this is pi over 2, and I want to go to pi. Okay, I want to stop right before pi. And then I have negative pi over 2 and negative pi. All right, so first I'm going to graph sine, okay? So what does the sine graph look like? Well, from 0 to pi, it just looks like this, right? And then from 0 to negative pi, because it's an odd function, it looks like this. Okay, so now what I want to do, right here in the dotted line, this dotted line here, this is y is equal to sine of x. Okay, so boom, looking back here. When sine of x is equal to 0, our cosecant graph has vertical asymptotes, right? Because you can never divide by 0. So I'm going to put a line up here, like this. And then, whoop, there's a vertical asymptote here. So it's going to go up like this. There's another one. And then where does sine have another, where does sine of x equals 0? Also at negative pi. Okay, so however I sketch the graph, okay, what I need to know is I need it to bump up against these vertical asymptotes. All right, now here's another thing. This graph actually has no x-intercepts. Like it will never cross the x-axis. Like you can't set 1 over sine of x equal to 0 and solve. You can't do it. But if you like take pi over 2, right? Sine of pi over 2, boom, is 1. So 1 divided by 1. So the graph here shares this high point with sine. And then all you're going to do is the graph has to literally butt up against the asymptotes that way. Just like that. Boom, boom, boom. And then on the other side, when you're at negative pi over 2, down here, sine is negative 1. 1 divided by negative 1 is negative 1. And then the graph is going to literally butt up against the asymptotes. So here's what you're doing, just to recap. You graph sine. And then when sine crosses the x-axis, you draw the vertical asymptotes up. Boom, 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 like I did. And then you just draw these u's in here. Okay, and the high point of the graph here touches the low point of the graph here, like this. And I don't know why I did that crazy sound effect, but you got the idea. And look, watch this. Let me show you something. If you were to plug in your calculator, let me show you sine of x. And then cosecant you plug in as 1 divided by sine of x. Watch what happens when I graph this. Here's sine of x in blue. And then in red you can see cosecant. And you can see exactly what I'm talking about. Right where you touch the x-axis, you have vertical asymptotes. And then where the graph turns from a valley or a peak, you have the graph of cosecant as a u touching it. So the key to graphing cosecant, okay, you graph sine, and then you use this method that I just showed you to sketch the graph. And don't worry, we're going to get a lot more practice with this, with the coming examples. All right, so the same thing holds here. Let's sketch. Now y is equal to secant of x on negative pi over 2 to 3 pi over 2. I'm changing this up because we're switching to cosine here. So again, all right, what's going on here? So, to sketch here, you're going to have to recall here in this one that secant of x is equal to 1 over cosine of x. So just like we did here, to sketch this, all right, so when you sketch y is equal to secant of x, first sketch y is equal to cosine of x. And then just watch what happens, okay? So here's negative pi over 2. Here's pi over 2. Here's pi. Here's 3 pi over 2. So again, what I'm first going to sketch here is cosine, okay? Not doing a great job, but you get it. And then cosine's an even function, so down here it looks like this. So look, same exact deal. Where cosine touches the x-axis, where it has its x-intercepts, you have the vertical asymptotes of secant. So again, it's the same deal. At 0, right, cosine is 1, so you get 1 over 1. So this graph of secant just looks like this. Butts up against the asymptotes. And then the same thing down here at pi. Okay? Cosine is -1. So 1 over -1 is -1. So this graph touches there as well, like this. And let me show you in the calculator here the same thing. So let me clear both these out. So let's graph cosine of x, and then 1 divided by cosine of x. And look what you get. Cosine in blue, and then secant in red. And you can see exactly the same thing. Where the blue graph touches, where cosine touches the x-axis, you have these vertical asymptotes for the red graph. So the key, boom, 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 what you see in the key for all of these, both these graphs, is you sketch either sine or cosine, and then you use those graphs to help you sketch the graphs of the other ones, okay? And then you use them to sketch, as I was saying, the graph of cosecant or secant. Okay, let's talk now about the properties of each before we jump into some examples, okay? So this is cosecant, okay? So cosecant, its period is every 2 pi, so it repeats itself every 2 pi. Its domain is all real numbers except integer. Sorry, a little bit of a typo. I've always been putting those in there. So except integer, multiples of pi. So look, at 0 pi, 1 pi, 2 pi, -1 pi, -2 pi, you have vertical asymptotes. In the range, okay, the range goes from, look, -∞ to -1, but then there's nothing between -1 and 1, and then it goes from 1 to infinity like that. All right, so the vertical asymptotes at integer multiples of pi, and this cosecant is an odd function here. Okay, that's because sine is also an odd function. Now secant, all right? Secant, kind of the same deal, okay? The period is 2 pi. The domain is all real numbers except odd multiples of pi over 2. 1 pi over 2, 3 pi over 2, 5 pi over 2, -1 pi over 2, -3 pi over 2. All right, the range, same deal as with cosecant. All right, it has to be less than -1 or greater than, less than or equal to -1 or greater than or equal to 1. And vertical asymptotes, as I said, at that odd multiples of pi over 2. And secant is an even function because cosine is an even function. Okay, let's jump in and do some examples. All right, so we'll start with these. These are kind of fun. All right, so it says use the following graphs to obtain the graphs of the corresponding reciprocal function, either the cosecant or secant, and give the equation of the function of the graph that you obtain. Okay. So look here. I've got y is equal to -1/2, all right, sine of x over 2. Okay. What is the reciprocal of sine? It's cosecant. Now, this is really cool how you do this, all right? You see where, so we're going to obtain the graph. Do you see where it touches the x-axis? That tells me there's vertical asymptotes, okay? And then follow this procedure I did. Low point here, so the graph is going to go like this. High point here, graph touches and then goes up against the vertical asymptotes. Low point, and then goes down against the vertical asymptotes. And then high point goes up the vertical asymptotes. Now the reciprocal function here, the graph of the reciprocal function in red here, you would think that you would flip this value in front, this -1/2, but you don't. That stays, so that's just -1/2. The reciprocal of sine is cosecant, and then whatever inside here, that doesn't flip or anything. All you're doing is just writing the reciprocal here of sine. Boom, that's it. That's all you're doing. You're not flipping anything else. None of the other numbers flip. Okay, here. Okay, we've got cosine. All right, so what is the reciprocal of cosine? That's secant. All right, so to sketch the graph, look wherever it touches the x-axis. You're going to draw the vertical asymptotes up. And now this is interesting. Do you notice how you only have a half here? All right, so you're only going to draw half of the graph on this side. So it's going to go and butt up here. Here, because I have both vertical asymptotes, it's going to butt up against both. Here, I have both vertical asymptotes. The graph is going to butt up against both. Down here, here. And because I only have the one side here, the graph is going to come up like this. So the graph in red here, y is equal to, again, leave the 1/2, okay? That doesn't change, okay? That's 1/2 secant of 2 pi x. That's it. All right, so all you're doing here, is you're using the graph of sine or cosine, and that's going to help you get cosecant or secant. Boom, boom, boom. All right, so let's now do some examples right from the start. Okay, so I'm just going to give you the graph, and you're going to have to graph, sine or cosine first, and then get the other graphs. Okay. So let's do cosecant first. Let's sketch the graph of it'll be very similar to what we just did, but y is equal to, let's do 2 cosecant of x over 2. Okay, and let's sketch the graph of this over 2 periods. All right, so I want to sketch 2 periods of this. Y is equal to 2 cosecant of x divided by 2. All right, so the way you do this is you take this. All right, what is the reciprocal here of cosecant? Well, that's sine, okay? So you're going to sketch y is equal to 2 times sine of x over 2, okay? And then you're going to use this graph to sketch y is equal to 2 times cosecant of x over 2. All right, so here, this is my a. Here, x over 2, my b is 1/2, and there is no c. So you're just going to go through, what we spent a ton of time talking about in those previous lectures, okay? The amplitude. That's equal to a, absolute value of a, so that's 2. The period is equal to 2 pi over b. So that's 2 pi over 1/2. Keep, change, flip, that gets me 4 pi. Then you find the quarter periods, which is just 4 pi divided by 4, which is just pi. And here there's no phase shift, okay? So you just go boom, boom, boom. You just sketch this sine graph incredibly quickly, all right? So I'm going to use this information here. You're going to see how quickly I'm going to do this. Like once you master graphing the sine graph, you've basically mastered graphing the cosecant graph. All right, so let me go to the next slide and I'll show you. So sketch 2 periods of y is equal to, we did 2 times cosecant of x over 2. Okay, so I'm going back and I'm going to sketch this sine. Okay, so my quarter periods are pi and I want to go over 2 periods. So I'm going to start at 0 and then pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. And we're our helper, okay? And we're going to be using the graph of this y is equal to 2 times sine of x over 2. All right. Well, what does sine look like, right? Sine starts at 0, goes up to the amplitude, down here. Here's the next x-intercept, and then it's just going to repeat itself, right? So look, wherever it crosses the x-axis, you have these vertical asymptotes. And look, just see how quickly this now goes? And I'm going to show you in the calculator this so you can see that indeed this worked. Just like that. Watch, let me grab the graphing calculator again. So this was 2 times sine of x divided by 2. And then we're doing 1 divided by 2 times sine of x divided by 2. Oops, so I made a little bit of a... oh, I put the 2. See, I'm sorry. So it should have been... This is my mistake. This is why you got to be careful. 2 times sine of x divided by 2. I put the 1/2. I put it as 1/2. Y is equal to 2 times 1 divided by sine of x divided by 2. There was my little bit of mistake there. There you go. Sorry about that. And you can see exactly what I'm talking about, how it touches the tops there, like I was saying. All right, so the key. So the key for any of these, cosecant, you're going to graph sine. All right, so let's do another one, just so you make sure we've got this. We'll do one with a phase shift now. All right, so let's sketch 2 periods of y is equal to 2 times cosecant of x minus pi. All right, so what we're going to do to help us, we're going to first sketch y is equal to 2 times sine of x minus pi. So this is my A, my B is 1, and my C here is pi. So my amplitude is the absolute value of A, which is 2. The period is 2 pi over b, which is 2 pi over 1, which is just 2 pi. Quarter period, you take 2 pi, you divide it by 4, you get pi over 2. And the phase shift is c over b. So this is just pi over 1. So we're going to now start at pi instead of at 0. Okay? And then look, hopefully, you know, we've graphed so much sine, okay, that once you have these things, you should be able to just very, very quickly go through and do this. All right. So let me go to the next slide and quickly, quickly sketch this for you. So we're going to sketch 2 periods of this y is equal to 2 times cosecant of x minus pi. And we're going to do it using y is equal to 2 times sine of x minus pi. All right, so the amplitude is 2. We're going to start at pi, and this is where it gets a little crazy. Your quarter period is pi over 2. So it's 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, 9 pi over 2, and then 5 pi. And then look, start at 0. You go up to 2, 0. You go down to -2 right here. 0. Do you see how quickly this goes? Go up to 2, 0. Go down to -2. 0. Wherever you have an x-intercept, you have a vertical asymptote. And then you can just boom, 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 sketch the graph, right? But up against the vertical asymptotes. My graphs aren't perfect here, because I'm doing it freehand with the stylus here, but you get the idea, you get the pattern. Like that. All right, we're going to do the same thing now with secant. And basically, same process. Instead of graphing sine, now all we're going to do is graph cosine. Okay, so I'll do 2 examples so you can see, how quickly this goes. Okay. All right, so let's sketch 2 periods of this y is equal to secant of pi x. All right? And so look, whenever you see secant, you're going to do this. You're just going to switch this graph. You're just going to say, okay, so to do this, I'm going to sketch the graph of y is equal to cosine of pi x first. So my a is 1, my b is pi, and there's no c, so there's no phase shift. All right, so my amplitude is the absolute value of a, which is the absolute value of 1, which is just 1. The period is equal to 2 pi divided by pi, which is just 2. And that's okay. Whenever we've done problems like this, whenever there's a pi in here, you're going to just get, some type of just generally an integer or a rational number here. Then your quarter period is just 2 divided by 4, which is just 1/2. And there's no phase shift. Okay, so there's no phase shift, so start at 0, all right? And let's sketch this graph. All right, so sketch 2 periods of this y is equal to secant of pi x. Okay, and we're going to do it using y is equal to cosine of pi x. All right, so start at 0, and then the quarter periods were 1/2. All right, and you need to get 2 periods in. So it's 0, 1/2, 1, 3/2, 2, 5/2, 3, 7/2, 4. And then amplitude was 1. So cosine starts at 1. Oop, that's terrible. But you get the idea what's going on here. Okay, so wherever you have an x-intercept, you have this vertical asymptote. All right. And look, this is weird because we only have a half part here, but look, high point and then just butt up against the asymptote. Low point here, you have to butt up against both asymptotes. High point above both asymptotes. Low point like this, and then whoosh, half one up like that. And we got it. If you want, I mean, you can extend either direction to make it look nicer, but here, this is just 2 periods. We've got it perfectly. All right, let's end by doing one with a phase shift, okay? So let's sketch 2 periods of y is equal to 2 times secant of x plus pi over 2. All right, now remember, whenever you see this plus in here, okay, you're going to really want to rewrite it as 2 times secant of x minus pi over 2. This is just going to help us, okay, identify the c correctly. So first, you're going to sketch y is equal to 2 times cosine of x minus pi over 2. So this is my a, my b is 1, and I've got my c correct here, okay, as negative pi over 2. So the amplitude is equal to the absolute value of a, which is the absolute value of 2, which is 2. The period is 2 pi over b, which is 2 pi over 1, which is just 2 pi. Quarter period is just 2 pi over 4, which is just pi over 2. And then there is indeed a phase shift. There is a phase shift here. So this is c over b. So this is minus pi over 2. That's why I did this. You have to remember this. Whenever you see the plus sign here, to write it as minus, or you're going to get it wrong, over 1. which is just minus pi over 2. Okay. So now once you do this, now that you have this all set up, it goes boom, boom, boom. It falls right into place. All right. So we're sketching 2 periods of. This y is equal to 2 times secant of x plus pi over 2. And we're going to do it using y is equal to 2 times cosine of x plus pi over 2. Okay, so go back. Phase shift was negative pi over 2. And then the quarter periods were every pi over 2. So you're going to just keep adding them. 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi. And then you're going to get the last one will be 7 pi over 2. And then the amplitude is 2. And look, so cosine starts up here. And you can see exactly what's going on. Just like that I had in the previous one. So wherever it crosses the x-axis, you get the vertical asymptote. And it's the same procedure. High point here, butt up against the vertical asymptote. Low point here, butt down against both vertical asymptotes. High point up here, butt up against both vertical asymptotes. Low point here, butt up against both vertical asymptotes. And then here, boom, butt up against the vertical asymptote. And we got it. So again, as you can see, the key here is to graph cosine and sine first. And then once you do that, then you can use the pattern I've illustrated here to help you sketch these graphs. All right, as always, you'll get a chance to practice this. And if you have any questions, please let me know.